Oh, hey everyone, I didn't see you guys there. Now, today we're gonna go over section 17A, algebraic proofs. Now, proofs are gonna be one of the biggest topics that you're gonna see in geometry because we're gonna reintroduce them often in several different chapters, and when the FSA time comes, you're likely gonna see 2 or 3 problems that have something to do with proofs. So we're gonna start you off a little bit easy and have you guys do algebraic proofs because most of us by now should know how to do a lot of algebra problems and just simple multi-step equations. So the first few properties are things that we should all be familiar with. So I'm going to kind of run through them a little bit quickly and then introduce you to 3 new properties that you probably haven't seen before. So the first property, of course, is the addition property of equality. And this is where we always say, like, if we want to get one number to the other side, you know how you add it to both sides? That's essentially what this property is trying to describe. The next property is the subtraction property of equality. Same principle. You're subtracting the same constant from both sides of the equation whenever you want to move something over. Multiplication property, you're multiplying the same constant to both sides. And the same thing with division. You're dividing both sides by the same number. And then for those of you who may or may not remember the distributive property, if you have a constant outside of a parentheses, you got to remember to distribute that to both terms on the inside. And when you multiply that constant to that, like for example, in this case, you have a times b plus c, you'll end up with a times b plus a times c. And then of course the substitution property, if you know that a and b are the same thing, whatever value, whatever expression or value you have for a, you can substitute that and, you know, ideally with parentheses, place that where b is located. So now the next one is the reflexive property. You're not going to see this property used too much in algebra, but it is something you're going to see often with the geometry proofs. And essentially it says that for any real number a, then a equals a. Again, I'm not going to spend too much time going over that now, even though that's obviously a is equal to a, but you're going to see that come up often in some geometry proofs, especially with triangles in the future. But then the symmetric property is saying that if you have a is equal to b, okay, then b is equal to a. All right? And this property is used a lot, especially at the very end. Like if you, they're going to be pretty picky about wanting the variable on the left side and the constant on the other side. And then over here, if we have the transitive property. So if we have, if a is equal to b and b is equal to c, right? So if a and b are the same and b and c are the same, then doesn't that mean that that these two are the same too, a and c? So that's what this is trying to say. So if a is equal to b and b is equal to c, then a is ultimately equal to c. All right, so this is kind of the format of what your proofs are going to look like. What they're going to do is they're going to give you some kind of given statement, and they're going to tell you, we want you to, given this statement right here, we want you to prove this over here. So in this case, given that 4x minus 1 is equal to 27, prove that x is equal to 7. Now, in the past, if I've ever given you any sort of problem like this, you guys would just go straight forward, add 1 to both sides, then divide by 4, and go and do everything you have to. But this time we're going to follow a specific process, and we're going to actually explain the reasons why each of those steps that you did actually works. So if you see right here, obviously the first line is always going to be your given statement. So we were given this equation, 4x minus 1 is equal to 27. That's given. The first line is always going to say given. Please don't forget that. And then you'll notice right here that the next line just says 4x is equal to 28. Well, if you would have done this on your own, you probably would have just gone ahead and add 1 to both sides, and then you would get to this step right here. But what they want you to do is they want you to give the reason for why this was possible. And then this is where knowing all of these properties, which for right now will probably let you see the properties or let you have them by your side. But at some point, you do have to memorize all of these properties. So make sure you understand the phrasing. So how was it possible that we got 4x equal to 28, or how was it possible that we got from this step to this step? Well, we used the addition property to add 1 to both sides of the equation. And then finally, in the next step, we have x is equal to 7. So if you would have done this on your own, you would have essentially just divided both sides by 4 and then gotten x is equal to 7. So if you think about the properties that you're given, the property that you used was the division property. All right. So again, proofs do get a little bit more involved in this, but for right now, we just wanted to start you off as simple as possible using concepts that you are already familiar with from algebra. So for this second problem, they went ahead and gave you this problem where you have a divided by 6 plus 2 is equal to 5, and they want you to prove that a is equal to negative 18. So again, if this is what they gave you, that's what you're going to write in this line right here for your given statement. And then you just got to go ahead and decide what are they doing from one step to the next. Here you notice that the 2 all of a sudden disappeared, but what they ended up doing was they subtracted the 2 from both sides, and now you just have 3 after the equal sign. And you got to remember, what was the property that they used? Well, if you subtract the 2, then you use the subtraction property. And then finally, to get the negative 6 to this side, what they had to do was they multiplied both sides by negative 6 to get 3 times negative 6 to get negative 18. So I kind of gave it away when I said multiplication. So multiplication property. All right, just got 2 more problems. And now that we kind of got the hang of this, it's going to be pretty straightforward from here. So this time they gave you the problem negative 9 times 2x minus 3 in parentheses is equal to 63, and they want you to prove that x is equal to negative 2. So again, you always start off with your given statement as your first line, and then from here you got to recognize that they went ahead and distributed the negative 9 to both of those numbers. So what the property you're going to use over here for step 2 is the distributive property. Distributive property. Don't mind my spelling. Kids always complain about it. But now for this one, when I have negative 18x plus 27 is equal to 63, what they did was they subtracted 27 from both sides to get 63 minus 27 is 36, so that they used the subtraction property here. All right, and then finally to get x by itself, they just divided both sides by negative 18, so here, as you can imagine, they used the division property. All right, now this last problem, we're finally going to start using some of the new properties that I taught you towards the end, at the end of that list from earlier. So if you're given 6x plus 7 is equal to 8x minus 17, prove that x is equal to 12. So let's just kind of follow along to see what steps they use to get to the final answer and fill out the property. So over here they have 6x plus 7 is equal to 8x minus 17. It looks like the 6x kind of disappeared on this side, which means that they probably subtracted it from both sides. So they used the subtraction property to get from step 1 to step 2. I'm just going to shorthand the property. And then over here they added, now from this step to this step, this negative 17 is no longer there, which means that they added that to the other side. So they use the addition property here. And then they use the division property for this last step to get the 2 to the other side. They divided both sides by 2. Right? And now notice over here when you have 12 is equal to x, like I said earlier, they always want the variable to kind of be on one side of the equation. Why? I don't know. But for some reason they're going to be picky about that. So if you, in order to get from this step to this step, all they essentially did was kind of flipped it. And if you kind of look back at all of the properties that we described earlier, the one property that shows that process is the symmetric property. So that's the one that we're going to put right here. All right, well, thanks for sticking along. And if you have any questions, just feel free to ask as per usual. And just hopefully this was helpful. Take care.